Hey, 8th grade. In this next video, I want to continue our study of factoring, and I want to review with you what we did last year, which was solving quadratic equations using the factoring method. So there's a difference between factoring a quadratic expression and solving a quadratic equation, and that difference is this. When you have a quadratic expression, let's just say x squared plus 5x plus 6, if you want to factor that, all you're doing is you're thinking of numbers that multiply to get 6 that combine to get 5, and you would factor that into x plus 3 times the quantity x plus 2. Okay, and then you would stop. Well, when you're solving an equation, it's a little bit there's a little bit more to it than that. You can still use factoring to solve equations, but equations you're going to be setting equal to 0 like this, and so there's always going to be one more step past this factoring part to solve an equation. You actually have to tell me what x equals. So in this case, you're thinking this times this equals 0, so what would x need to be? And that's where this zero product property comes in. Okay, you know that since if two numbers multiplied together give you 0, then one of those two numbers has to be 0, and so that's where you just assume that either this expression x plus 3 equals 0, or this expression x plus 2 equals 0, which means x has to be either negative 3 or negative 2. Okay, so this is something we did a little bit last year, but we're going to review that again in this video. So there's basically two steps to solving quadratic equations by factoring. The first step is to, if the equation is not already set equal to 0, set it equal to 0. And then the second step is to factor the expression, okay, just like we did right here, and then use your zero product property to determine what x would need to be. Okay, and again, oftentimes for quadratics, you'll get two answers for x, just like we did in this mini example up at the top. So now let's move down to example 1, and we'll just practice this process for each of these examples 1 through 6. So number 1, we have x squared plus 5x minus 6 equals 0. We're already set equal to 0, so now I'm just going to factor the left side. I need a positive and a negative, since my constant term is a negative 6. I need numbers that multiply to get negative 6, that combine to get positive 5. And so that's going to be a positive 6 and a negative 1. Okay, is how this expression here will factor. So then, because I'm set equal to 0, I know that either x plus 6 must be equal to 0, or x minus 1 must be equal to 0. Okay, and so that means that x would either need to be negative 6 or positive 1 to make this equation true. And so what we say is that there are two solutions to this equation, and those two solutions we're going to put in braces. The solutions are negative 6 and positive 1. Those are both x values that would make this entire equation true. Just remember, you can check each of your quadratic equations by graphing this in your calculator. If you were to graph this function on your calculator, you would get a parabola that has two x-intercepts, or two zeros is what we call them, one being at negative 6 and one being at positive 1. Okay, so that's a way to check yourself on each of these quadratics here to see if you're doing it right. Okay, is to graph each equation on your calculator and checking to see where the x-intercepts are, where the zeros are. Okay, looking at number 2 now, we have x squared minus 7x equals negative 12. For this one, our equation is not set equal to 0, so we want to add 12 to both sides in order to do that. So you get the equation x squared minus 7x plus 12 equals 0. Okay, and now I need to factor this expression on the left side. So I need two of the same sign, since we're multiplying to get a positive 12 here. And since your middle term is negative, that means I need two negatives. Negative 4 and negative 3 will both multiply to 12 and combine to get negative 7. And so that means that x can be equal to positive 4 or positive 3. So your solutions to this equation would be positive 4 and positive 3. Okay, number 3, we need to set this equation equal to 0, so we're going to subtract both x and negative and 4 from both sides. That will give us 3x squared minus x minus 4 equals 0. And then to factor this left side here, I need to use my slide and divide method, since my leading coefficient is 3. So this becomes x squared minus x minus 12 equals 0. So x squared minus x minus 12 will factor into x minus 4 times the quantity x plus 3. And then because I slid my 3 over, that means I need to divide now by 3. This gives me x minus 4 thirds times the quantity x plus 1 equals 0. Now, the nice thing about solving an equation by factoring is I do not have to go the step further and make this 3x minus 4 over here in this expression. Okay, I could still do that if I wanted to. So this one would become 3x minus 4 times the quantity x plus 1 equals 0. So we know one of our answers is going to be negative 1. Okay, the other answer, though, if you think about it, we're going to take 3x minus 4, and we're going to set that expression equal to 0. Well, if you solve this expression for x, you end up getting positive 4 over 3. Well, look what we had over here before we did all this. Okay, x minus 4/3, if you just set this equal to 0 and add 4/3 over, you get x equals 4/3. Okay, so when you're actually solving an equation, there's no need to do this step right here because you're still going to get that same answer of 4/3. Okay, so really this part here is unnecessary to do when you're solving an equation. When you're just plain old factoring, though, and stopping, then you still need to do that process there. Okay, but solving an equation, we can just stop right here and say our answers are 4/3 and negative 1. Now looking at number 4, we have the equation 7x squared equals 21x. So I'm going to subtract 21x from both sides. And that gives me the expression 7x squared minus 21x on the left side equal to 0. This time we have a binomial on the left side. So to factor my binomial, I'm going to factor out my GCF. My GCF in this case would be 7x. And I'm left over with x minus 3. Okay, so in this case, I've really got two expressions. I've got 7x times the quantity x minus 3. Okay, so this x minus 3 here is going to give me one solution of positive 3. My other solution, though, I'm going to get from this 7x. If we take the expression just 7x, okay, there's no plus or minus anything, and set that equal to 0, the only way to get this part equal to 0 is if x itself is 0. So this is a case where if you ever factor out a variable as a GCF, that means that one of your zeros is going to actually be the number 0. Okay, so your solutions to this equation number 4 are going to be the numbers 3 and 0. Looking at number 5, we have 16x squared plus 24x equals negative 9. So the first thing I'm going to do is add 9 to both sides. And now I get 16x squared plus 24x plus 9 equals 0. The first thing I notice is that both my first term and my last term are perfect squares. So I'm going to do my perfect square trinomial test and see if this is a perfect square trinomial. So the square root of 16x squared is 4x. The square root of 9 is 3. 4x times 3 is 12x. And if we double that, we get 24x. Okay, so that means that this is in fact a perfect square trinomial. So to factor this, all I need to do is take the square root of 16x squared, which was 4x, plus the square root of 9, which was 3, and make that a quantity squared. So you get 4x plus 3 quantity squared equals 0. And now to actually solve this equation here, 4x plus 3 quantity squared would be the same thing as 4x plus 3 times 4x plus 3. So really, you're only going to get one solution for this. Okay, if you set both of these equal to 0, since they're the same thing, and solve for x, you end up getting x equals negative 3 over 4. So there's one solution to this equation right here, and that would be negative 3/4. Okay, finally number 6, we have 8x squared plus 1 equals 6x. So I'm going to subtract 6x from both sides of my equation. That's going to give me 8x squared minus 6x plus 1 equals 0. I will need a slide and divide on this one. So that gives me x squared minus 6x plus 8 equals 0. When I factor this, it's going to factor into the quantity x minus 4 times the quantity x minus 2. And then I need to divide both my negative 4 and my 2 by 8 to get me x minus 1/2 times the quantity x minus 1/4 equals 0. Okay, so that means I have two fraction zeros for my answer here. Positive 1/2 would be one of them, positive 1/4 would be the other one. Okay, now to the back side, we're just going to take a look at a quick word problem. So for this one, it says a woman drops a front door key to her husband from their apartment window 64 feet above the ground. So if you want to picture this as a graph really quick, This is what we did with our quadratic modeling in the last part of the unit. Okay, here's where the key's starting. The key's starting up here at 64 feet off the ground. Okay, and then the key is going to fall, and then eventually at some point in time here it's going to hit the ground where it's going to be at 0 feet. So the first question is asking how long, so we're supposed to find x, okay, does it take the key to reach the ground? That means y value is equal to 0. Okay, so we're going to use this equation here, y equals negative 16x squared plus 64. Okay, because negative 16, that's always going to be your leading coefficient with these falling object problems, and 64 here is your starting height of the key. And we're going to solve that equation assuming that y is equal to 0, okay, because we're assuming that since the key is hitting the ground, that the height is 0. So now we want to find what is x when y is equal to 0. So we're going to solve this equation right here by factoring. If I factor negative 16x squared plus 64, I can factor at a GCF of negative 16, and that's going to leave me with x squared minus 4 when I factor at a negative 16. X squared minus 4 is a difference of squares, so when I continue factoring this, I get 0 equals negative 16 times the quantity x minus 2 times the quantity x plus 2. Okay, and now let's talk about what our solutions would be. Negative 16 times this has to be equal to 0. Well, obviously negative 16 itself is not 0, so really that's not affecting our answer here. What we need to consider is x minus 2. If x minus 2 itself is 0, then x is equal to 2. If x plus 2 is equal to 0, x is equal to negative 2. Well, we're trying to find time here. So for this problem, we're not going to take any negative answer since we can't have negative time. So that means my only answer to this problem is x equals 2. So that means the key lands here at the point 2, 0, or it takes 2 seconds for this key to hit the ground. Okay, part B of this is asking what are the reasonable domain and range for this situation? Well, that goes back to what I was just talking about with time. Okay, so your x values, which is your domain, are dealing with time here. Okay, we can't have time be negative, so I would say that the minimum value here for x is 0, okay, because time can't be negative. The maximum value for time, well, the key hits the ground after 2 seconds, so that means that the only time this key is falling is from 0 seconds to 2 seconds. So I would say that the domain for this graph, for this situation, is all x values from 0 to 2. The range, you're going to do the same thing we just did with time, except you're going to think of the y values of that starting point up here and this ending point. Okay, my minimum y value would be when the key is on the ground, so that would be y is 0. Okay, that's my smallest y value. The highest y value, or the maximum y value, would be the highest point, or the point it was dropped from, which was 64 feet. Okay, so a reasonable range for this situation would be all y values from 0 to 64. Okay, if you need to, feel free to rewatch anything in this video that you just want to look back over again. And until I see you next time, have a nice day. You're all wonderful people. Take care.